The next type of transformation I want to talk about are reflections. And just like a reflection in a mirror, just like reflections you've talked about in art class. And of course, they will result in a congruent figure. When you look in a mirror, you see the exact same thing looking back at you. It's not like a funhouse mirror where it's going to be distorted or different. It's going to be same shape and same size is what congruent means. So for a reflection, we're given the line of reflection, which this is our rule. So the rule is to reflect this across y equals -2. Well, something you need to know, if you've got y equal to a number, that line will be a horizontal line, which is opposite of what we think because the y-axis is vertical, but again, we're going through where y equals -2. And if you're doing x equal to a number, it's going to be a vertical line through that number on the x-axis. So for example, where y equals -2, I'm going to find y equal -2 here. And if I run a line up and down, I'm not hitting just -2, I'm hitting all the other numbers. But if I run a line this way, and again, it's an imaginary line, so I just want to kind of pretend it's there. If I run a line that way, I'm hitting every point I hit has y as -2. This is 1, -2, 2, -2, 0, -2, 5, -5, -2. So again, the point is everywhere y is -2. If you were to draw a line this way, these are not all -2. So now once you've gotten that, we can start reflecting. And if you recall from the first slide, reflections are the same distance. The points are going to be the same distance from this line of symmetry or line of reflection. So pick one point to start with. So I'm going to start with Q. And it looks like I am 1, 2 away from the line of symmetry. So I'm going to go 1, 2 in the other direction. And that's my Q prime. You're going to cross over the line of symmetry, kind of like Red Rover. X, let's go X next. Go 1, 2, 3. I'm 3 away from this line of symmetry, so I'm going to go 3 the opposite direction. 1, 2, 3. And this is X prime. E, it looks like I'm 1 away, so I'm going to go 1 in the opposite direction. There's E prime. And I, it looks like it's right on the line of symmetry, so it's going to be the same exact one. So I prime is actually going to be the same as I. If it's on the line of symmetry, it's not moving. Think about if you put your finger on a mirror, your finger is touching your finger. There is no distance between them in the mirror. Same thing here. I'm ready to connect now. I should have the same shape and the same size, but in this case, it'll be a reflection. It's just kind of moved a little bit. And I do. I definitely have it. It might be a little different looking, and that's because I drew out my coordinate plane, which means my increments might be a little tiny bit off. But if you were to use a formatted coordinate plane that you got off the internet or in a textbook or some graph paper, it would look exactly the same, just flipped up. Looking at number 2. We're going to go, sometimes they're across the x-axis. So if I want to go across an axis, the axis is my line of symmetry. So pretend like you're folding a piece of paper across that line and the image is going to end up in the opposite direction. So if I go across the x-axis, how far is A away from the x-axis? It looks like it's 1, 2, 3, so go 3 in the opposite direction. 1, 2, 3. So I'm 3 below. There's really no shortcut for this one. For me, it works a bit better visually, and it might for you too for a while until you get the hang of it. D, looks like I'm 5 away. 1, 2, 3, 4, 5. So I'm gonna go 5 the opposite direction. 1, 2, 3, 4, 5. Should be right across from each other, just in a different location. Again, remember this is your axis of symmetry. It's the x-axis this time, and that's D prime. M, same distance from as D, it's 5 away, so let's go 5 the other direction down here. M prime. And W is only 1 away from M, so just to make my life a little easier, I'm just going to do that. Because it's right above and below it, I'll get the same thing. Let's Let's go ahead and connect them. And I have the same shape and the same size, just in different locations. Again, if I were to fold this in half, this would end up down here upside down. The last one I want to talk about is a little trickier, and it's the line y equals negative x. This is very similar to slope-intercept form. If you can kind of imagine this as slope-intercept form, there's a 1 implied here, and when there's nothing added or subtracted, it's always implied to be plus 0. So if you're looking for this line of symmetry, it's not vertical or horizontal, it's on a diagonal. So y equals negative x, if I start at 0 and went down 1 over 1, I get there. And then down 1 over 1, I get here. And I can reverse the direction then, go up 1 over 1 to give me a good idea of where I'm at. So that's how we're going to get this one. When you have x and y together, they work on a diagonal. I'll do one more just to make sure I get a good diagonal, since I'm not dealing with graph paper here. Okay. And I'm going to do one more this direction. Looks about right. Okay. So this is the line I'm reflecting over this time. This is my line of reflection. So if I was to fold the paper here, this figure would end up down here, just reflected, not facing the same direction. But they are the same distance away from the line still, but you got to count on the diagonal. So in this case, it looks like I am one diagonal away. So I want to go one diagonal away in the other direction, which is going to put me here. Again, if you were to see all the grid marks, you kind of draw some in there so you can see what I'm talking about. This one, let me do one more here. From here to this point, here's my square on my grid. I am one diagonal from that line of symmetry. So I want to go one diagonal in the other direction to find my A prime. Okay? Same thing with S. I am 1, 2.5 away. Let me use red to kind of help us out a little bit here. I am actually a little bit more than that. This looks like it's at 2. So I am 1, 2, 3 away. So I need to go 3 in the other direction. There's my 3. 1 diagonal, 2 diagonals, 3 diagonals. So I'm going to go 1 diagonal, 2 diagonals, and a 3rd diagonal. So it looks like my S point will end up being about here. This will be my S prime. And I need to do the same thing for T. Go on the diagonals. So I am 1 diagonal. I am 2 diagonals. 3. Oh, I counted wrong. I'm 1 diagonal away. And a half. So I'm going to go 1.5 the other direction. So a half plus 1 should put me right, let me see, half plus 1 should put me right here, I believe. And again, this is a little harder without the graph paper, but just remember to count the diagonals. If I was to graph these, I'm pretty much, actually I think I got this one a little low, it should have been up here. Should get the same shape and same size, so I would need to reevaluate this one to make sure that it's coming out like it's supposed to. Again, if you were to imagine it flipped down, same shape, same size. Some of the other issue could be the increments that I drew might be a little off, which would be hard to therefore get an accurate result. Remember, if it says to go across, x-axis or y-axis is easy, but let's say I say go across the x equals 3 line. Just real quickly, as a recall, if you see this, you want to go find where x equals 3, which is right there, and you want to go up and down through it, because that's where every point will have the x coordinate as 3. So that would be the line of symmetry if it said x equals 3. If I went this way, I'm hitting x equals 3, x equals 2, x equals 1. I'm not just hitting 3. So watch out for that with those type of problems. If you see y is equal to x, that line of symmetry would be just like we talked about, except in the positive direction instead of the negative direction. Let's look at that last problem again. Since it didn't work out exactly like I wanted to, let's take a look at that again. So again, let's put the line, it said to reflect over across y equals negative x. So again, that would be right here, going through the origin. So this is the line, y equals negative x, okay? And the points will reflect across that line, and not counting horizontal or vertical. Since this is a diagonal line, I want to count on the diagonal. So as you can see, A is one diagonal away from that line, so I'm going to go one diagonal away in the other direction and say that that is my A prime. T, I was right, it is 1 plus a half of 1. So if I go a half in the other direction plus 1 more, I will find T prime. And lastly, S, count 1, 2, 3 diagonals, and I want to go through the other direction. So 1, 2 diagonals, 3 diagonals. So that is where my S will end up. This is looking much better. S prime. So again, when we're doing a diagonal line of reflection, count on the diagonal. How many diagonals away from that line? Connect the points, and this one is going to look more congruent, same size, same shape to the original as opposed to the other one I drew out. Continuing on with reflections, let's now talk about the rule. So deciding what is the line of symmetry. Again, I think I would just pick 2 points, kind of like we did with translations, to focus, and then make the line of symmetry from there. So I'm going to pick F, and if I look, when you're doing a reflection, you're trying to find the middle between the original point and the resulting point. So it looks like the middle, halfway between these, is right here. So if I were to draw a line, imagine a line between these 2 points. It looks like F reflects to F prime. K, remember they have to be the same distance away. Looks like it's the same distance from K prime. There's K and there's K prime. V, looks like that's the middle between there. Let's see, V is 1, 2 away, and V prime is 2 away as well. And J is 1 away on this side, and J prime is 1 away on the other side. So it looks like the line that created that was on the y-axis. So this is y equals, because it's going through a y value on the y-axis. And it looks like it's at y equals 2. So this rule would be across y equals 2. Over here, I'm going to pick T prime and T. And they're diagonal from each other, which tells me the line of reflection will also be diagonal. So the middle is like right in here. Oh, and it looks like the shape is right on the line of symmetry even. Some of the ordered pairs are. So that line here, it's slanted in the negative direction like we learned in slope with slope-intercept form. And if we go down 1 over 1, we keep hitting a point on that line. So this rule is across y equals negative x. If it had been going this direction, if they had reflected in this direction, the line would have been y equals x. And again, that would have looked like this. So if the points were to reflect from here to here, that's reflecting over the line y equals x. Again, imagine that you're folding the figure across that imaginary line and you should get the resulting points. So for number 2, y is equal to negative x. Okay, our last problem, again, we want to write a rule for this. We want to figure out, again, what the line of reflection might be. If you'd like to pause the video to try to figure it out, feel free to. So this one here, I'm going to pick R prime and R. And it looks like these are 1, 2 away, so that would be the middle right here. If I were to fold it, I would get the resulting point. If I were to fold this, that's where G would end up. G prime is 4 away, and G is also a distance of 4 away. So since I'm right on the axis, I say which axis I need to cross. So I want to go across the x-axis. If you had drawn a line on the y-axis, you would have said across the y-axis. That would be, if this had been the line of symmetry, this figure would ended up over here. Also recall, if I said to go across x equals -1, remember go to where x equals -1, which is right here, and it's a vertical line through it, which is the opposite of what the x-axis goes. And again, we're doing that because that means everywhere on that line, x is going to be -1. At this ordered pair, that's -1, 1. Up here, this is -1, 3. Down here, I'm at -1, 2. So everywhere on this line, x equals -1